Dear students, in my last lecture I have explained about alcohols, monohydric alcohols and dihydric alcohols. In dihydric alcohols I have explained method of preparation of dihydric alcohols and reactions of dihydric alcohols. Now in dihydric alcohol last is pinacol-pinacolone rearrangement. Pinacolone rearrangement. What is pinacol? Di-substituted dihydric alcohols are called pinacol. For example, dimethyl butane diol. This is called pinacol. When this pinacol is treated with acid H2SO4 and heat, it undergoes dehydration minus H2O to give pinacols. CH3, 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 CH3 and double bond. This is tertiary butyl methyl ketone. This is called pinacolone. So this rearrangement is called pinacol-pinacolone rearrangement. Now the mechanism of this reaction is this pinacol plus H positive. It undergoes protonation OH2 positive, and this water molecules leak out OH and there is carbocation. Now this methyl group migrates to this positive carbon. Positive charge shift from this carbon to this carbon. Now this oxygen has lone pair of electron. Double bond OH, positive charge on this oxygen. Minus H positive. CH3, C double bond O. CH3, CH3. This is pinacolone, and this rearrangement is called pinacol-pinacolone rearrangement. Now, if this pinacol, this dihydric alcohol is unsymmetrical. For example, this is pH, CH3, CH3, OH and OH. Now there are two hydroxyl group. Which hydroxyl group will leave? The hydroxyl group which that give more stable carbocation departs. H positive, pH, positive, CH3, CH3 and OH. Now, if this OH departs, then the positive charge will be on this carbon. Now, if the OH on carbon bearing phenyl group leave, this carbocation is, now which carbocation is stable? This carbocation which bears to phenyl group is more stable because the positive charge is delocalized on the two phenyl rings. So this carbocation is more stable, and then shift of this methyl group. This methyl group shifts CH, CH, CH3, CH3, OH positive and minus H positive, C, PH, PH, CH3, C, H3 double bond. This quinaclone will be formed. So phenyl will not shift, but methyl will migrate on the carbon having positive charge. Now, if the two phenyl groups OH, OH, this is pH, this is pH, and this is C6H4OCH3, and this is C6H5OCH3. The migrating aptitude of phenyl is more than methyl, methyl is more than hydrogen, and in phenyl the migrating aptitude of methoxy is more than phenyl, toluene, and toluene is more than phenyl, and phenyl is more than para-chlorophenyl. So in this group will migrate and phenyl will not migrate on rearrangement. C6H5OCH3, pH, pH, C6H5OCH3 and double bond. So this quinaclone will be formed. So this is about quinaclone rearrangement. This rearrangement is important for your examination point of view. Now your next topic is epoxides. What are epoxides? Three-membered cyclic ethers are called epoxides. This is a cyclic ether. This compound is called epoxide. Nomenclature in common system, they are called alkylene oxide. So this is ethylene oxide. In IUPAC system, this may be called alkene oxide. This is ethene oxide, or it is called epoxy ethane. So this is nomenclature. Next is method of preparation of epoxide. Epoxides can be prepared from alkenes. Alkenes, when treated with perbenzoic acid, CH2 double bond CH2 plus perbenzoic acid RC double bond OOH. This is perbenzoic acid. It gives in the solvent used is inert solvent. They give CH2, CH2. So when alkenes are treated with perbenzoic acid in inert solvent, they give epoxide. The mechanism of this reaction is C6 H5, C double bond O H. This is perbenzoic acid. It will give CH2, CH2O epoxide plus C6H5COO benzoic acid. So these alkenes give epoxides. So second method is when alkenes are treated with hypohallous acid, HOH. This is hypohallous acid. It gives first CH2, CH2OH and X. This is called halohydrin. So this halohydrin, when treated with a base AOH, it gives CH2, CH2O. This is epoxide plus K. Now, if we use hypochlorous acid, HOCl, we will get this chlorohydrin. This will give epoxide and ACl. So, this is the second method for the preparation of epoxide. On large scale, epoxide are manufactured by passing ethene gas and air. From air, we use O2. When a mixture of ethene and oxygen is passed over silver catalyst at high temperature 573 Kelvin at high pressure. When the mixture of ethene and air is passed over silver catalyst at high temperature in presence of high pressure, we get epoxide CH2, CH2O. So, two molecules will give two molecules of epoxide. So, these are the method of preparation of epoxide. Next is reactions of epoxide. Now, for question point paper examination point of view, ring opening of epoxide. Epoxides are unstable. There is strain in the three-membered cyclic ring. So, this ring opens in acidic medium as well as in the basic medium. So, acidic hydrolysis of epoxides. Epoxide in acidic medium H2O. We will get CH2, CH2OH, OH. So this is glycol. In dihydric alcohol method of preparation of glycol, I have explained this reaction. Now the mechanism of this reaction: CH2, CH2O epoxide plus H positive. Protonation take place, OH, positive charge on oxygen. Now water molecule, oxygen has lone pair, it attacks on this carbon and we get CH2OH and OH2 positive. Removal of H positive, CH2OH and CH2OH. So this is the mechanism of hydrolysis of epoxide in the acidic medium. Next is basic hydrolysis. Hydrolysis of epoxide in the basic medium. In basic medium, again the reaction OH negative H2O. Again we get same dihydric alcohol. Now the mechanism is this OH, it attacks on this carbon, ring opens, CH2, CH2, OH and O negative. Next step is water molecule give H positive, CH2, OH and CH2, OH minus H positive. So this is the mechanism of basic hydrolysis. Now, what is important? Regioselectivity. When there are unsymmetrical epoxide, CH2C, there is methyl, methyl and O. Now this is unsymmetrical epoxide. This epoxide opens in acidic medium as well as in basic medium, but now it will give different products in acidic medium and basic medium. It can give CH2, OH, CH3, CH3, O, CH3, or CH2, CH3, CH3, OH, O, CH3. When reaction takes place in presence of methanol in acidic medium or in the basic medium. In acidic medium, the nucleophile attacks the more substituted carbon, whereas in basic medium the nucleophile attacks the less substituted carbon. H positive and CH3OH. Means you can also write plus CH3OH in acidic medium. The product will be CH2OH, CH3, CH3O, CH3. CH2, CH3, CH3O plus OCH3. In basic medium, sodium methoxide, it is a strong base, and in presence of methanol, we get CH2OCH3, CH3, CH3. Simple epoxide in acidic medium as well as in basic medium, hydrolyzed ring opening take place, gives same product, whereas in unsymmetrical epoxide in acidic medium and in basic medium we get different products. Why this difference take place? Now in acidic medium there is first protonation. Plus H positive. This protonation takes place. Now this out of these two carbon, which carbon has more positive character? The carbon which bears two alkyl group can accommodate the positive charge more than this carbon. So this carbon has more positive character and the nucleophile attack on this carbon, more substituted carbon. Whereas in basic medium, the factor is both in acidic medium as well as basic medium mechanism is SN2. But in basic medium, the nucleophile attacks the less substituted. First it attacks the less substituted, means less hindered. This carbon is more hindered and this carbon is less hindered. So methoxy group attack on less hindered carbon. So it gives the product this one. So the difference in getting products in acidic medium and in the basic medium. Now next reaction is reaction with Grignard reagent and with alkyl lithium. So first Grignard reagent, that is RMGH. This is Grignard reagent. For example, C6H5 MgBr plus CH2CH2O. This is ether epoxide, sorry. It gives C6H5 CH2CH2O MgBr, and this undergo hydrolysis. H2O in acidic medium, C6H5 CH2CH2OH. So we get this alcohol. Now next is reaction with alkyl lithium. Alkyl lithium, for example, N-butyl, CH3, CH2, 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 lithium. This is alkyl lithium, N-butyl lithium. Now again, this ring opens. CH3, CH2, 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 lithium, and it undergoes hydrolysis in the acidic medium to give alcohol. CH3, CH2, 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 and this is hexanone. So these are the reactions of epoxide with alkyl lithium and with Grignard reagent. So your topic on epoxide is over. You are left with only phenols. In next lecture, we will explain phenols. Thank you.